how delightful it is to have a section of Young and Freedman's University Physics that's pretty simple to understand. This is section 6 of chapter 15. Although any physics book will have a section on wave interference, boundary conditions, and the law of superposition. So let's get this over with. So some basic definitions. The overlapping of waves is called interference. It's not a hard concept. Let's say that there's a wave of water that is headed toward a wall, and then it bounces off of the wall. So the initial pulse going toward the wall is called the incident pulse, and then as it bounces off, that's the reflected pulse. Okay, and what happens is that if you have a series of waves, going and they bounce off, then they can begin, or if you have two waves, let's say you have two people who drop two rocks into a pond, and they start a wave from both of those rocks. Eventually, those waves are going to interfere with each other. They're going to hit each other. So, but let's go back to this idea of you have an incident wave that bounces off of a wall, off of a boundary, say. It could be a string. The example in the book is a string, that is tied to a wall, and the wave hits the wall and bounces off. If the boundary is fixed, like a wall or a string that's fixed at the end, then the displacement as it comes off, it's going to be opposite in direction. So you have the incident, and then the reflected wave is going to be opposite in direction, and it's going to be opposite in orientation too. So if the wave comes and hits it up high, then when it's reflected, it's going to be reflected, well, if it's attached, it's going to go opposite as it goes away. So you're going to see the invert, as it were, of the wave as it reflects off of the wall, if the boundary is fixed. Now, if the boundary is free to where it can jiggle and it's not fixed, then the wave will reflect in the opposite direction, but it will do it in the same kind of pattern that you had before. And there are pictures in the book, or any book, that would show you this. So basically, if the boundary is fixed, the reflected wave is going to be opposite in orientation or end displacement, up and down displacement. But if the boundary is free, then it's going to be the same in its displacement as it reflects off of the boundary. So I've been using the word boundary. So whether the end is fixed or free, that's what we call boundary conditions, the conditions of the boundary. Is it a fixed boundary or is it a free boundary? Okay, we're almost done. The other part of this section, pretty short section, is the principle of superposition. And the idea here is that when any two waves overlap, the displacement at any point is going to be a matter of adding the two waves together. So, if they were perfectly, aligned, it could have double the amplitude, or if they're perfectly out of sync, they could cancel each other out and you could have a zero amplitude. But basically, you're just going to add up the waves. So if you have wave 1 and wave 2, y1, y2, these are going to add to, and you're going to have the total new wave, as it were, yxt. Just add them together. It's very simple. This only works for linear systems. So if it weren't a linear equation is a series of variables that are only raised to the first power. If we had squares or cubes or something like that, this wouldn't work. But the principle of superposition works for most waves, because most waves are linear. Anyway, if you didn't understand that part, you're fine. Just remember that you add up the amplitudes of the waves when they're interfering with each other. And that's pretty much this section.